Hello, on this video I'm going to talk about pointers, specifically raw pointer and smart pointer. For that I'm going to open Visual Studio and I'm going to create a new project, C++ console application. And here's my project. I always delete these comments. Good. So now let's start by creating a variable. I'm going to create int x and then I'm going to assign a value. The value is 10. Alright, so if I print the value of x, so I have a problem. I'm going to hover over, show potential fix. I'm going to add the namespace standard and that should fix it. Good. So if I do a cout on x, I'm going to display what's called the value of x. So if I run this program now, it shows me that the value of x is 10. All right, that's great. So now let me copy and paste this line of code, and then instead of printing x here, I'm gonna put the ampersand sign and x. So when I put the ampersand here, I'm not printing the value of x, I'm printing the actual address of x. So I'm gonna run this program, and if you notice here, it prints the value of x and then prints the address of x. This is a hex value that represents the address of x. So let's pretend this is memory. And in the memory, you have a lot of locations, and each location stores a value. This is not in reality how memory works, but this is just a visual representation of how that would work. So pretend this is memory, and then pretend that right here I create a variable called x, and then inside the variable called x I placed the value of 10. So the value of x is stored on a memory location and the value there is a 10. But then this memory location has an address, this memory location has an address, and so on. Every single memory location has an address. So what is the address? What's the index of this memory right here? So the index of this particular memory here happens to be this number. So this number is the address of this location. So the address of this one here will be this number that ends with 24, and then the next location will be this number that ends with 25, and the other location would be also this number here, but instead of 25 it would be now 26, and so on. And remember, it's a hex number, so all these numbers right here, and then you just add 1. So again, there's a difference between the value of the variable and the address of the variable. The value is the actual value store, and the address is the index of each location. So each location has a sequential address. Now, one thing that's interesting here is that if I run this program again, the value of x still will be 10. However, the address of x will change. And that's because on this computer right now, there is several hundred, maybe thousands of processes working at the same time. And all those processes are using memory. So every time a new process fires up, it uses this memory location here for whatever reason. It stores a string or whatever it is. So they end up using this space. So next time I run this program, x will not be stored on this address right here. X may be stored right here next time I run, or right here. I don't know. So just by curiosity, I'm going to run this program again. And now you notice that the address changed. So the value is the same, but the address changed. And that's because the program ran again, and between me closing this program and running it again, some other program came and cleaned up that memory location and assigned to some other process that's running on this computer right now. So you can never guarantee the same memory location twice. As a matter of fact, you can guarantee you will never get the same memory twice. All right, so back to the code here. So this is the value of X, and this is the memory location of X. Now, if I can print this, then I can assign to a variable. And if I can print this as well or display this, I can also assign to a variable. So you would think they would create a variable called pointer, and then you would point that to the address of X. However, this doesn't work because this variable is expecting a value, and then this ampersand and the X is a address. If I declare this pointer as a address, then I can save the address of X in a variable called pointer. So now, if I want to display the value of PTR, all right, so now I'm going to run this program. And if you look right here, now what happened is that I have a memory that's something like that. And then when I declared X, I put the value of 10 right here inside. So the value of 10 is here inside. And the address of that memory location happens to be this big number here that ends with F854. So it's a big number that ends with F854. This memory location here is going to be the same big number that will end with F855. And that happens throughout the whole program. Now, whenever we create a pointer, we create somewhere here a pointer, PTR, and inside this pointer, we put this value, and this value happens to be a memory address. So right here in PTR, we put this big number that ends with F854. So what I want you to take from this explanation here is that when you declare a variable, inside the variable, it stores the actual value of the variable. When you create a pointer, it stores a address of whatever it's pointing to. In this case, this pointer points to a address, and this address happens to be the address of the variable X, and inside the variable X we have the value 10. So again, when you declare a variable, you store the value. When you declare a pointer, you store the address of something else. Always the address. Now I'm pretty sure you have a burning question now, that if I print the value of PTR, of pointer, can I print the address of PTR, you absolutely can. So let's try to print the value of PTR of the pointer and the address of the pointer. So if I run this program now, and here's my memory again. When I declare the X, I store the value of X here. So that's the value of X. So this is my variable X. And the address of this location happens to be this number right here. So this is the address. So it's a big number that ends with F884. Then right after that, I created a pointer. And I don't know where the pointer is stored, but let's say the pointer is stored right here. So this is the pointer. And then inside this pointer, I stored this value here. So this value here got placed inside this memory location. And this value right here happens to be a big number that ends with F884. But this memory location right here also has an address. And the address of this location here happens to be this guy here. So the address of this thing here is a big number that ends with F8A8. So F8A8. So again, the whole point here is that variables have an address and you can store a value inside that address. Pointers, the value of pointers is the address of something else. In this case here, it's the address of the integer x. However, the pointer, it is stored in the memory, and that memory also has a memory location. So everything has a memory location. The pointer stores memory location. So the pointer stores memory location, the variable stores values. All right, so let's move on here. So since I create the pointer right here, I can also change the original value of x just by using the pointer. So my pointer, if I assign the number 21 to the pointer, that is not gonna work because the pointer, remember, is an address and 21 is a value. But I know the pointer is pointing to x and I want to change the value of x. So if I want to change the value of x, which is my original variable, I need to put a star here. And this star here tells me that I'm not changing the pointer, I'm changing where the pointer is pointing to. So in this case here, when I run line 13, I'm saying whatever address the pointer is pointing to, place the number 21 there. So if this is my memory, and then I store 10 right here on location X, and then I declare a pointer and point to X. So now I have another memory location and then I have the address of X right here. And once I put a star to the pointer, it points to the actual original location of x. So this here will change the value of x. So I'm going to put the same code here just to display the value of x right after I changed the value of x. So I'm going to run this program, and here you can see that I had 10 for the value of x. Then I changed the value of x here on line 13, and then finally I print the value of x again, and then I have 21. All right, so now I'm going to create a very quick class right here. Very quick class, and the class does nothing for now. However, I do have a class, and I'm going to include the car class right here. I'm going to include the header of the car class. And then here, I'm going to instantiate an object type car. So car, C, car, my car equals new car. So when I use the new operator right here, it actually creates space in memory. And this space in memory here is saved on something that is actually a pointer. So the way you declare right here, the syntax to declare here is the same one that you used to create the pointer. So my car is just a pointer. So if my car is a pointer, then I can create other variables and also point to my car. So I can create another pointer. My car 2 equals my car. So now what I have here on line 19 is 2 pointers pointing to this exactly the same thing. So right here, if I print the value of the mark_i pointer and the value of mark_2 pointer, they point exactly to the same location. So I'm gonna run this program, and if you look right here, Gary, they're exactly the same. That means I can use either of these pointers to call any function or data member within the mark_i class. Now, this thing here is what's called the raw pointer. And the raw pointer has a problem. It must be deleted before you finish the program. So before I finish the program, I must delete my car. So now what happens is that once you delete, you're not going to have any type of memory leak. So if I run this program, everything works, but right before you deleted the my car. Now, when it comes to raw pointers, you only have to delete whatever you created using the new operator. So in this case right here, you did create a pointer, a raw pointer, that points to a variable x. So you do not have to delete this pointer because you did not create with the new operator. So only delete pointers that you created with the new operator. So this is raw pointer. Raw pointer happens to be old, and also I would like to recommend you don't use it. All right, so if you cannot use the raw pointer, then what should we use if we're not going to use the raw pointer? The solution is to use something that's called a smart pointer. So this is new technology. This is what you should be using. All right, so let's create now a object type car, but instead of using the raw pointer, we're going to be using the smart pointer. So to create a object with smart pointer, we're going to type unique pointer, and then the less than and bigger than sign, and then right here you're going to put the data type, and the data type of this pointer happens to be car. So we're going to create a pointer that points to car. Next is the pointer's name, whatever you want to put it here. If you want to put banana, that's okay, but let's put a name that makes sense here. So this is going to be a car pointer, and then within parentheses we're going to put the actual initialization of that class using the new operator. So here I'm going to put the new and then the class. So this is how you initialize a class, or this is how you instantiate a class using the smart pointer. And then once you do that, the car pointer can be used any way you want to use. The same way you're using the raw pointer right here, you can use the car pointer going forward. Now, one of the difference, besides this being very, very new, better technology, better design, is that we do not need to delete. So you do not need to delete your car pointer before you end this program. So this is not needed. So do not try to delete. So even though you do not delete, you will not have memory leak, just because this is a newer and better way to write pointers. And you can use the smart pointer in the same way practically that you can use the raw pointer. So I can call the car pointer, and you can call, I do not have any function on my car. So let me create a quick function here. Very quick, very simple function. So now here I can call that function, do this function, and if you run this program, the do this function gets called, and then I print hello world right here. All right, so the summary right here for this thing is that variables store values and pointer stores addresses. The second thing is, once you have the address, you can change the original value that the variable is pointing to. The next thing is that a raw pointer is quite old and it must be deleted if you use it. So I recommend you not to use it. Don't use it. Try to use the smart pointers as much as possible. Now, smart pointers, newer technology, better architecture. It's just a different way to instantiate the objects. But then once you instantiate the objects, you can use the object just like you use any other objects. and you do not need to delete. As a matter of fact, if you try to delete, you're going to have an error. So don't delete it. All right, so that's all for this video. Thanks for watching. So right here, if I print the value of the mark-high pointer and the value of mark-2 pointer, they point exactly to the same location. So I'm gonna run this program, and if you look right here, Gary, they're exactly the same. That means I can use either of these pointers to call any objects cuts. That means I can use either of these pointers to call any function or data member within the mark_r class.